Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Here is Vitamath 57. This is about calculus. Evaluate limit of cube root quantity cube root of x minus 1 over square root of x minus 1 as x approaches 1. So this is an indeterminate case because when x approaches 1, the numerator approaches 0 and the denominator approaches 0. So I will present three approaches, three methods here so that you will have your own way in evaluating limits, especially of these indeterminate forms. So the order or index of the radical in the numerator is 3 and in the denominator is 2. So let's make these expressions to have common index, and the that is 6. So let's make the numerator difference of two squares. So let's make this x to the 1/6 quantity square minus 1 square. While the denominator, let's make it difference of two cubes. So x to the 1/6 quantity cube minus 1 cube. So limit as x approaches 1 of cube root of x minus 1 over square root of x minus 1 equals limit as x approaches 1 of x to the 1/6 quantity square minus 1 square over x to the 1/6 quantity cube minus 1 cube. So we have difference of two squares. The factors of difference of two squares are x to the 1/6 plus 1 and x to the 1/6 minus 1. While the factors of difference of two cubes, so we have x to the 1/6 minus 1 quantity square of x to the 1/6, which is x to the 1/3, then plus the product, which is product of x to the 1/6 and 1, which is x to the 1/6, then plus the square of 1, which is just 1. So we write this as x to the 1/6 plus 1 times x to the 1/6 minus 1 in the numerator, in the denominator x to the 1/6 quantity x to the 1/6 minus 1, square of x to the 1/6 is x to the 1/3, the product of x to the 1/6 and 1 is x to the 1/6, and the square of 1 is 1. Cancel out x minus x to the 1/6 minus 1, so we have limit as x approaches 1 of x to the 1/6 plus 1 over x to the 1/3 plus x to the 1/6 plus 1. Since if we substitute x equals 1, both the numerator and the denominator do not approach 0, so we are safe to substitute x is 1. So limit therefore is 1 to the 1/6, which is just 1 plus 1, over quantity 1 to the 1/3 plus 1 to the 1/6 plus 1. So the numerator is 2, the denominator is 1 plus 1 plus 1, 3. Therefore, it is 2/3. Then for the second method, let's have L'Hopital's rule. Remember that this is applicable whenever we have indeterminate forms. The numerator approaches 0 as well as the denominator. So we differentiate individually the numerator and the denominator until such time that when x approaches a certain value, when we substitute, it is no longer an indeterminate form. So by L'Hopital's rule, the derivative of cube root of x minus 1 or 1 or x to the 1/3 minus 1 is 1/3 x to the negative 2/3. So that would be limit as x approaches 1 of 1/3 x to the negative 2/3. The denominator is 1/2 x to the negative 1/2. So both the numerator and the denominator no longer approach 0 as x approaches 1. So we are now safe to substitute the value of x. But before that, let's simplify. It is equal to 2/3, then x to the 1/2 over x to the 2/3. So to make the exponents positive. So limit as x approaches 1 of 2/3 of x to the 1/2 over x to the 2/3. Substitute x equals 1. So both x to the 1/2, 1 to the 1/2, and 1 to the 2/3 are 1. So therefore, the limit of cube root of x minus 1 over square root of x minus 1 is 2/3. Then, by using the calculator, the limit of a function exists if both the left hand and the right hand limits are equal. So since x approaches 1, we mean we have to substitute value of x just to the left of 1 and a value of x just to the right of 1. So just to the left of 1 to 4 significant figures, 0.9999, and we have to use the calculator here. So cube root of x minus 1 over square root of x minus 1, limit is cube root of 0.9999 minus 1 over square root of 0.999 minus 1. So because you have to use the calculator, the value of that in decimal form is equal to 0.66667, or that's approximately 2/3. Then let's also verify or show that the right hand limit is almost equal to this or equal to this, approximately equal to 0.6666 or 2/3. So we substitute 1.001. So limit of quantity cube root of x minus 1 over square root of x minus 1 equals cube root of 1.001 minus 1 all over square root of 1.001 minus 1. So using the calculator, the value is equal to 0.66666, and that's about 2/3. So the left hand and the right hand limits are equal. Therefore, the limit exists and it is equal to 2/3. So that's it, and I hope that you were able to follow the explanation and the solutions. And this is important for high school students and for college students. For those who are reviewing for their licensure exams, this is also important.